Something unusual is happening in the world of technology right now, quietly, almost under the radar. A machine is learning to move, balance, think, and work in ways that used to belong only to humans, not in a lab experiment, not in a science fiction movie, but in the real world. Factories, warehouses, workplaces, and the company pushing this moment forward is the same company that already disrupted the auto industry, reshaped energy markets, and forced the entire world to rethink transportation. Tesla. But this time, the breakthrough isn't a car, it's a humanoid robot. And what makes this moment so shocking isn't just that Tesla built one. Robotics companies have been trying to do that for decades. What's shocking is how quickly Tesla's humanoid robot is improving, and what that improvement could mean for the global AI race that is already reshaping the future of power, labor, and technology. Because if Tesla succeeds in building a truly capable humanoid robot, it won't just change factories. It could redefine the entire relationship between humans and machines. And suddenly, companies, governments, and entire countries are paying very close attention. For years, robotics development moved slowly. Progress was real, but it was incremental. Robots could assemble car parts, move boxes in warehouses, or perform extremely specialized tasks. But they were rigid machines built for narrow jobs. They couldn't adapt, they couldn't learn on the fly, and they certainly couldn't operate in the chaotic, unpredictable environments humans navigate every day. Humanoid robots were considered one of the hardest challenges in engineering. Walking on two legs alone is incredibly difficult. Balance, perception, motor control, spatial awareness. Humans do these things automatically, but for machines, each movement requires complex computation. That's why early humanoid robots were impressive, but limited. Companies like Honda spent decades developing robots like Asimo, which could walk and perform simple gestures. Boston Dynamics stunned the world with machines capable of backflips and parkour, but these robots were demonstrations of engineering excellence, not practical workers ready to reshape industries. And then Tesla entered the conversation. When Elon Musk first announced the Tesla bot concept in 2021, many people dismissed it. Critics called it a distraction. Others assumed it was a marketing stunt. After all, building electric cars was already an enormous challenge. Creating a general-purpose humanoid robot seemed almost impossible, but Tesla had something other robotics companies didn't: an AI ecosystem already built at massive scale. Every Tesla vehicle on the road is essentially a mobile sensor platform collecting enormous amounts of real-world data. Cameras, neural networks, computer vision systems, all designed to understand the physical world in real time. And that technology turned out to be exactly what a humanoid robot needs, because before a robot can move like a human, it has to see like one. Tesla's advances in computer vision, neural networks, and AI training gave it a powerful starting point. The same systems designed to help cars navigate streets could help robots understand rooms, objects, tools, and obstacles, and suddenly the impossible challenge of humanoid robotics began to look achievable. Tesla's humanoid robot, known as Optimus, started as a rough prototype. The early versions were slow, somewhat awkward, and clearly still in development, but something interesting began happening behind the scenes: iteration speed. Tesla began improving the robot rapidly. Motors became more precise, hands gained more dexterity, balance improved. The robot's ability to manipulate objects started to look less like a research experiment and more like a potential worker. At Tesla's AI Day demonstrations, the robot began performing real tasks: carrying objects, sorting items, navigating spaces. Still early, still imperfect, but the trajectory was unmistakable. And this is where the story becomes much bigger than one company, because humanoid robots are not just about technology, they're about economics. Imagine a machine that can do physical labor, operate tools designed for humans, work 24 hours a day, and learn from AI models trained on massive data. Factories could transform overnight. Warehouses could operate with minimal human labor. Construction, logistics, manufacturing, entire sectors could change dramatically. And Tesla isn't the only company racing toward that future. Across the world, robotics companies have been accelerating their efforts. Boston Dynamics, now owned by Hyundai, continues to develop some of the most advanced mobile robots ever built. Their machines move with uncanny agility, navigating terrain and obstacles that would challenge even humans. Figure AI, a fast-rising startup backed by major investors, is building humanoid robots specifically designed for industrial work. Their robots aim to perform repetitive tasks in factories where labor shortages are already becoming a major issue. Even companies like Amazon are investing heavily in warehouse robotics, seeking ways to automate large portions of their global logistics network. But the competition doesn't stop with corporations, it extends to entire nations. China, for example, has declared humanoid robotics a strategic priority. The Chinese government has invested billions into robotics development, viewing automation as a key component of future economic dominance. Chinese companies are now producing humanoid prototypes capable of complex movements and tasks. Universities and research labs are rapidly advancing AI-driven robotics. Europe is also entering the race. Robotics research across Germany, Switzerland, and other countries continues to push boundaries in mechanical design and AI integration. What we're witnessing isn't just technological progress, it's the beginning of a global robotics race. And whoever wins that race could gain enormous economic and geopolitical advantages. Because the implications are staggering, a workforce of intelligent machines could reshape productivity in ways never seen before. Manufacturing capacity could explode, labor costs could shift dramatically. Countries that master humanoid robotics might gain the ability to build more, faster, and cheaper than their competitors. That kind of advantage can change global power structures, but technology never moves forward without raising difficult questions, because the same robots that could revolutionize industry could also disrupt millions of jobs. Manufacturing workers, warehouse employees, delivery drivers, even certain service roles. Automation has always replaced some jobs while creating others, but humanoid robots introduce a new dimension. Unlike traditional machines designed for one task, these robots could adapt to many different roles, which means the scope of automation could expand far beyond anything seen before. And this leads to a deeper question that technologists and policymakers are beginning to confront. If machines become capable of performing a large percentage of physical labor, what happens to the human workforce? Some believe new industries will emerge just as they did during past technological revolutions. Others worry that the transition could be far more disruptive. And the ethical questions don't stop there. A humanoid robot powered by advanced AI raises questions about autonomy, responsibility, and control. If robots become more intelligent, more capable, and more integrated into daily life, how much decision-making should they be allowed? What happens if machines begin interacting with the world in unpredictable ways? And who is accountable if something goes wrong? These are questions the world has barely begun to answer. Meanwhile, the technology keeps advancing. Tesla continues refining Optimus, training its neural networks with ever larger data sets. The company's massive AI infrastructure, including the powerful Dojo supercomputer, is designed to train AI models faster and more efficiently. That kind of computing power could accelerate robot learning dramatically. Instead of programming every behavior manually, Tesla aims to teach robots through AI, allowing them to learn skills the way humans do: observe, practice, improve. If that approach works at scale, humanoid robots could evolve much faster than traditional robotics ever allowed. And that possibility is what has many experts paying close attention. Because once robots reach a certain threshold of capability, adoption could spread rapidly, factories could deploy thousands, warehouses could operate with fleets of robots working around the clock, entire supply chains could transform, and the effects would ripple across the global economy. But perhaps the most fascinating aspect of this story isn't just what robots can do today, it's what they might become tomorrow. Imagine humanoid machines assisting elderly populations in aging societies, helping in disaster zones too dangerous for human responders, supporting healthcare workers in overloaded hospitals, exploring environments that would otherwise be inaccessible. These possibilities hint at a future where robotics becomes deeply integrated into everyday life, not just in factories, but everywhere. And yet there is still so much uncertainty. Technology has a way of evolving in unexpected directions. The internet began as a research network. Smartphones started as communication tools. Today, they shape culture, politics, economics, and daily human behavior. Humanoid robots could follow a similar path. What begins as an industrial tool might eventually become something far more complex. Machines capable of interacting with humans in ways we are only beginning to imagine.